All right, our project's on Apple AI Siri. We're group 2. My name's Yarda Woke.
My name is Doyan Adiyama.
My name is Jonathan Water. My name is Abraham Michael.
My name's Jonas Lalo.
First, we'll start off with the breaking down the AI chain. Let's start with how Apple Siri collects data. Siri pulls in a wide range of data types from audio and text inputs to metadata like language settings and device types. When users say, "Hey Siri," or press the Siri button, that triggers data collection across all Apple devices. Apple emphasizes privacy. Only a small portion of data is relevant and reviewed for quality control, and only if users opt in. They also use something called differential privacy, which adds noise to data to make sure individual identities can't be traced back to them. This keeps the data useful for analysis, but also keeps them anonymous. So when Siri gets smarter, users stay protected as well. Moving on, we have data pre-processing. So now that we talked about how Siri collects, let's look at what happens next with pre-processing. One thing is raw audio isn't ready to be used as is, so Apple cleans it up first, removing background noise and static using signal processing. Then comes transcription. Siri uses deep neural networks to convert speech into phonemes. These are like building blocks of sound, or like the smallest unit of sound. Then recurrent neural networks help Siri understand the context of the sentence, so it knows whether you're saying right or right. There's also anonymization where Apple strips any identifying info, and because Siri is used around the world, Apple trains its models with different accents and dialects, so it can understand people no matter where they're from. And then for the next part, we have how Apple stores that data. Siri's data storage is Siri's setup is all about balancing security, privacy, and speed. On device storage lets Siri work locally on your iPhone using secure Enclave and Apple neural engines. This speeds up responses and keeps sensitive data only to your device, so ensuring privacy as well. When Siri needs to use the cloud, Apple uses its own data centers at its own facilities and headquarters and encrypts everything, both while it's being sent towards them and while it's sitting in storage. They also separate voice data from account info, so it's hard to reconstruct user identity even in a breach. For scalability purposes, Apple uses robust databases like Apache, Cassandra, and massive storage clusters, so Siri stays responsive even with millions of users.
Going into the model training, so Siri gets smarter by using speech recognition and natural language processing to figure out what we're saying and what we mean. Behind the scenes, it's powered by some pretty advanced models like RNNs and LSTMs, which is long short-term memory, and newer transformer models like BERT and Whisper that help Siri handle everything from short commands to full conversation. Siri learns from a mix of real-world data like transcribed speech and structured user queries, and is trained using a blend of supervised and semi-supervised learning to cut down on errors over time. What's really cool is that a lot of its training actually happens right on your device through something called federated learning. This means your data stays private, but Siri still gets better at understanding you. And of course, this is made possible by the power behind it, Apple's custom AI chips and cloud GPUs that keep everything running smoothly and quickly. When it comes to model evaluation, and it comes to making sure that Siri works well, Apple takes model evaluation really seriously. They use key performance metrics like word error rate, precision, recall, and F1 score. These help measure how accurately Siri understands both what you say and what you mean. Testing isn't just in a lab either. Apple mixes public benchmarks with their own private test data. And they even do live A/B testing with real users to compare old and new versions. Siri's also stress test in tough conditions. Things like noisy environments, rare languages, or unusual phrasing, so it holds up in the real world. And beyond the numbers, they run fairness audits to bring in human reviewers to spot subtle errors or biases that automated tools might miss. They also pay attention to how people use Siri. So if users repeat themselves or stop engaging, that's a sign that something didn't work and is getting flagged for improvement. All of this ties into ongoing monitoring. So if a model starts slipping in performance, it's restrained or replaced, all while keeping user privacy protected. So next we'll go into model deployment of Siri AI. Apple uses a hybrid deployment strategy, which means Siri operates using a combination of on-device processing and cloud-based systems. After the models are trained, they're optimized using core machine learning, Apple machine learning framework that ensures everything runs efficiently across different Apple devices. A key piece of this is the ANE, which is Apple Neural Engine, a chip built into most Apple devices that allows Siri to handle lightweight tasks like voice recognition, word detection, and basic commands all directly on that device. This helps Siri runs faster, saves the battery, and most importantly supports Apple's strong stance on user privacy, keeping the data local. But at the same time, if you have more complex tasks, like finding directions or connect to a third-party service that's routed in Apple's cloud infrastructure, the request is handled with a powerful model, and the response is sent back to the device quickly. This dual setup is local for fast tasks, like private, and for cloud is on deeper computation, and this helps Apple scale Siri capabilities while performing high performance and user trust. Next, we'll go into output generation. First of all, when a user speaks, Siri uses an on-demand device voice recognition to convert the audio into text out, and the user actually wants, whether it's sending a timer, sending a text, or asking what the weather is. If it's a simple request like that, Siri completes the task locally without needing internet access and makes the process fast and privacy friendly. But if it's a more complex task like checking the weather or searching online, Siri then sends that to the cloud service and it has to be approved by a third-party API. These services handle the request, then pull the data, and then return the results to the user. Finally, Siri uses a text-to-speech engine to deliver the answer out loud and also displays it visually on the screen. This voice response has become more natural and human-like thanks to the recent upgrades in machine learning. This whole process from voice input to spoken and visual output is what makes Siri feel smooth and very user-friendly.
Next, we have intermediate AI components. So firstly, to deliver seamless voice interaction, Siri relies on several intermediate AI components that work together behind the scenes. So it starts with speech recognition, which converts the user's voice into text by using deep neural networks. And this often happens on device using Apple's neural engine, which ensures fast performance and protecting user privacy. Then the natural language understanding, or the NLU system, interprets the meaning behind the words and identifies the user's intent, extracting key entities or names or dates to understand the context. And once the intent is understood, Siri is able to use dialogue management to maintain the context and multi-step conversation. So if I ask, for example, what's the weather, it'll then follow up with how about tomorrow. So Siri understands exactly what you're referring to.
Additionally, model optimization plays a role. Apple uses Core ML to convert large cloud-trained models into versions that run efficiently on iPhones and other devices. After generating a response, Siri uses text-to-speech to convert back into spoken language with a natural tone. Additionally, to support tasks like checking the weather or setting reminders, Siri uses middleware and APIs to securely connect with external devices and services without overwhelming the device. Siri also has error handling and learning. So when things go wrong, say there's background noise or unclear speech, Siri uses error handling and fallback strategies like prompting the user again or reprocessing the input. Behind the scenes, Apple uses continuous learning, where automated user interactions help update models over time, and personalization, which allows Siri to learn from your habits and preferences, continue to keep your data updating while also secure through encryption and on-device processing. Altogether, these components form a complete AI pipeline, transforming raw voice input into intelligent, privacy-conscious responses that reflect both technical precision and user awareness. Next, we have the financial performance stats. So first, we'll talk about the revenue growth. First, Apple doesn't give out all the information about how much they make money from certain things, specifically about Siri, so it's more of a broad sense of how AI is implemented in their systems. But in recent memory, in quarter 4 of 2024, iPhone revenue hit $46.22 billion. That's a 6% year-over increase from the previous year. A big part of that was due to the recent iPhone 16 being launched, but with the iPhone 16 being launched, there's also advanced Siri features under the Apple Intelligence brand. Users were drawn in by the features like smart Siri responses, personal suggestions from Siri, and also just better natural language processing. On the service side, with Apple Music, App Store, iCloud, and any AI-powered feature like personalized playlists and app suggestions help drive engagement that helped the segment of the services hit nearly $25 billion, up almost 12% from the previous year. And investors are also noticing. Financial institutions like Morgan Stanley, JP Morgan, and Wedbush all raised their Apple Stock targets, pointing to AI as being a key and prominent reason for its growth. So in short, Siri isn't just a smart assistant, it's also a revenue generator.
All right, going into the cost savings, Siri also plays a big role in cutting costs, especially by reducing the need for live customer service. So think about it, when Siri can schedule appointments or check your calendar with just a voice command, that's one less call going to a human support agent. Across the board, voice assistants are expected to save companies around $8 billion a year by 2026, according to Juniper Research, which is huge. For Apple, using Siri to handle more user requests means fewer resources spent on human support. So it's a win, both in terms of cost and efficiency. And because Siri runs directly on Apple silicon chips, like the M1 and M2, it doesn't have to rely as heavily on cloud servers. That reduces bandwidth and cuts back on expensive servers. It cuts back on expensive server operations as well. So getting into return on investments, we started with the basic ROI formula, and then searching sources online, we found that Siri was bought in 2010 for $200 million. We found their ongoing research and development costs from 2010 to 2024, and we estimated a 10% of Apple's research and development went to Siri. So this brings the total estimated investment to $20.85 billion for Siri. So according to a Bank of America financial advisor, securities analyst, Siri is projected to have $50 billion in revenue over the next 10 years, or to bring that into Apple. Since not all revenue is profit, we found that Apple averages about 43.3% of that in net profit on average. So we take the estimated gross profit and we multiply it by the 43.3, and we get 21.65 billion. So then we subtract that we take that and then we subtract the initial investment, and we get 0.8 billion. So plugging that into the initial ROI formula, we get about an ROI of 3.84.
So this is a conservative estimate because it's based off the prediction from the Bank of America analyst, but it doesn't account for intangible benefits like brand loyalty or ecosystem stickiness. But overall, it's still beneficial for Apple to implement.
So next we'll go into the market share of Siri. In quarter four 2024, Apple led the global smartphone market with a 23% market share, and this outperformed Samsung's 16% market share. And a key driver of that success is Siri, and that's how it helps make the iPhone experience way more intelligent, private, and seamless. Siri supports Apple's brand identity by offering intuitive AI tools that align with their privacy-first approach. But there's also growing pressure. Google and Samsung are already launching more advanced AI features and staying ahead of the curve, like real-time translation and on-device summarization, which gives them an edge in the innovation-focused consumers. Finally, it's also important that iPhone still makes up over 50% of Apple's total revenue, so continuously improving the experience for users, especially with AI, is critical for this. However, in quarter four of the past year, iPhone shipments declined slightly, which shows how important it is for Apple to stay ahead in AI. As the smartphone industry shifts towards the AI-first experiences, Apple's ability to enhance Siri and deliver more advanced capabilities will be key to protecting growing competition in their market.
Now let's talk about how users feel about Siri today. Because even with all the improvements that Apple has made, satisfaction has been kind of mixed reviews. Back in 2012, when Siri was first launched, people were really impressed, and according to Wall Street Journal reports, users loved how convenient it was. But even then, there were some frustrations that came up, mainly with Siri not understanding complex or contextual commands. Since then, Apple has done a lot of things to improve that. So they've added on-device machine learning, and they've upgraded text-to-speech engine, and they rolled out better natural language processing. So Siri sounds more human and responds way faster now. And in 2023, the Apple Intelligence updated helped a lot. It made Siri more aware of the context and better at personalizing response, which did improve the experience for many users. And the statistical survey in 2024 showed that 71% of the users were satisfied with Siri, which is good, but still behind Google Assistant, which scored 81%. The big issue is that Siri still struggles with multi-turned conversations, where users have to have a longer back and forth. But on the positive side, the privacy with Siri is that it really shines. And according to research, about 65% of Apple users say they prefer Siri specifically because of the stronger data protection policies. And even with the gains in speed and the usability that Siri has earned, people still expect more. And Siri is still behind tools such as ChatGPT or Google Gemini when it comes to conversational depth or creativity. But in short, Apple has made a lot of progress with its customer satisfaction, and it shows, and there's still room to grow.
Finally, we'll go over our mock AI model. This is the URL for the dataset, and then in the next video, we'll go over what we created and how we created it. Hello, I'm Abe from Group 2, and in this video, I'll be walking you through the mock AI model that we created. It simulates a simplified version of Apple's Siri, specifically focusing on how it might detect emotion in text and respond with differing outputs, mimicking human empathy. Let's break down how we built the model and used it to generate Siri-like responses based on sentiment classification. So, to start, we found a Kaggle emotion dataset, which contains tweets with various phrases. Each tweet is paired with a number from 0 to 5, representing one of these emotions based on the sentiment expressed. You can find the dataset at this URL, and we will also link it in the slides. To prepare the text for analysis, we started by lowercasing all of the text. Then we removed stop words and non-alphabetic characters to eliminate noise. We also applied liminization, which reduces words to their base form. These steps help our model focus only on the most meaningful and relevant parts of each tweet. Since machine learning models cannot understand raw text, we use TF-IDF vectorization to turn these clean tweets into numbers. This method helps highlight the most important words in each tweet so the model can focus on patterns that actually reflect emotion. Then we trained a random forest classification model to predict the emotion behind each tweet. After training, we evaluated the model on a test set. It achieved an accuracy of about 88%, which is especially strong on emotions like joy and sadness. While it's not perfect, it performs very well for a lightweight sentiment classification model. To visualize how well our model performed in each emotion category, we created a confusion matrix. Each row in the chart represents the actual emotion, while each column shows the emotion predicted by the model. The diagonal values show correct predictions, and we can see that the model did especially well with emotions like joy and sadness, with 635 for joy and 536 for sadness, correct predictions. There were some mix-ups between similar emotions, which is understandable given how subtle the differences can be. The confusion matrix not only highlights the model's strengths, but also shows where it tends to make mistakes, giving us insight into how we can improve or adapt the model in future versions. Finally, to bring our model to life, we created a Siri-style response generator. After predicting the emotion behind a sentence,
Our model responds with a supportive or empathetic message similar to what Siri might say in a real-world scenario. Let's try 2 out right now. So, if I tell my model, I'm really nervous about my exam tomorrow. It predicts the emotion as fear, and the Siri responds back with, I've got you. Want help finding a grounding exercise? I'm going to try one more. I'm so glad to be alive right now. And when we run, we can see that the model predicts the emotion joy, and it responds, that's awesome. Want me to save this moment? So, our key takeaways, and to conclude, we saw that emotion classification is achievable with a lightweight model. Room for improvement when it comes to distinguishing between similar emotions can be found through our confusion matrix. And our simulation shows the potential for emotional AI to enhance voice assistants in the future, allowing them to respond with greater empathy and emotional awareness. As this technology advances, it could play a key role in making digital interactions feel more human and supportive. Thank you for watching.
Thank you for listening to our presentation about Apple Siri AI.